Hello students, today we will discuss about quick sort. Quick sort. This algorithm uses the idea of divide and conquer. It finds the element called pivot which divides the array into two halves in such a way that elements in the left half are smaller than the pivot element and the elements in the right half are greater than the pivot element. Quick sort algorithm works as follows. There are three steps involved in quick sort. First, find the pivot element that divides the array into two halves. Second, quick sort the left half, and third is quick sort the right half of the array. Example: consider an array having 6 elements 5, 2, 6, 1, 3 and 4. Arrange the elements in ascending order using quick sort algorithm. Assign array index with each element of the array. There are certain pointers used in quick sort. First is left, initially pointing to the first element of the array. Next pointer is right, which initially pointing to the last element of the array. Last pointer used in a quick sort is pivot, which initially pointing to the first element of the array. We have to divide our array in such a manner that left half of the pivot should contain the element smaller than it and the right half of the array should contain the elements which are greater than pivot element. Rules to be remembered are: all elements to the right of pivot be greater than pivot element and all elements to the left of pivot be smaller than pivot element. Let's start solving the above example. So we will start from the right and move towards the left and check for the smaller element from pivot. If there is any element present which is smaller than the pivot element, we will interchange the position of that element with the pivot element. When we are checking from right and moving toward the left, we encountered first element, that is 4, which is smaller than 5. So we will swap the position of pivot and the 4. So the new array is 4, 2, 6, 1, 3 and 5. 5 remains the pivot element. Now the pivot element is pointing at right, so we will start from left and move toward right and check for any element which is greater than pivot element. If any element present, so we will swap the position of that element with 5. 5 is being checked with the first element from the left, that is 4. 4 is smaller than 5, so there is no need to change its position. So we will move our left pointer towards the right, that is left will become left plus 1. Now 5 is being checked with 2. 2 is still smaller than 5, so there is no need to change its position. Now 5 is being compared with 6. 6 is greater than 5, so its position get interchanged. Now the new array is 4, 2, 5, 1, 3, 6 and pivot element is present at index 2. Now the pivot element is pointing at the left, so we will start from the right and move toward the left and check for any element which is smaller than 5. If any element present, we will interchange its position with 5. 5 is being compared with the rightmost element, that is 6. 6 is greater than 5, so there is no need to change its position with 6. Hence, the right counter will move toward the left, that is, right will become right minus 1. Now, 5 is being compared with 3. 3 is smaller than 5, so its position get interchanged. Because on the left side all the smaller element than 5 must be present, and on the right hand side all the greater element than 5 should be present. Now the new array becomes 4, 2, 3, 1, 5, 6. Pivot element is present at 4th index. 5 is being compared with 4 and 2 already. So now we are comparing it with at index 2, that is 3. 3 is smaller than 5, so there is no need to change its position. So we will increment the left counter, that is left equal to left plus 1. When 5 is being compared with 1, 1 is smaller than 5, so there is no need to change its position. Now both left and right are pointing at the same element of the array. So this time 5 is a pivot and it is at its sorted position. That is, all elements present toward the left half are smaller than the 5 and all the elements present at the right half is greater than 5. So 5 is adjusted to its sorted position. We will now quicksort the left subarray, that is 4, 2, 3, 1, in a same manner as we have sorted 5 at its current position. The sorted array comes out to be 1, 2, 3, 4, 5 and 6. Analysis of quicksort. In best case, the best case analysis assumes that the pivot is always in the middle. To simplify the maths, we assume that two sublists are each exactly half the size of the original. So Tn is equal to Tn by 2 plus Tn by 2 plus 1 leads to Tn equal to big O of n log n. In average case, Tn is equal to big O of n log n. In worst case, when we pick minimum or maximum as pivot, then we have to go through each and every element. So Tn is equal to big O of n square. Thank you.